Hi, I'm Grega Milcinski, come from Sinergise, and I'll talk about Cloud-Native and ZARR within Sentinel Hub. For those of you who don't know what Sentinel Hub is, it's basically a set of APIs that make it seamless to get large amount of Earth observation data in machine learning workflows and applications. It contains of a stack-compliant catalog API so that one can see what is in there, and then there are APIs to get analysis-ready data out of it, where analysis ready depends on what user wants. Some would want the original reflectance value, some NDVI or the imagery tiles or time series or whatever. There is a level of processing that can be done so that one can really fine-tune how he would like to have the data delivered. Now, most of the use is within machine learning workflows, which is why there is some capacity available focused to that, like large-scale feature generation for raster data, or if one has hundreds of thousands of polygons and would like to get time series, again, a dedicated feature. The most important part, though, is that it basically covers all relevant open data collections, as well as the most important commercial ones. And we are talking about more than 50 petabytes of data, and the catalogs are always up to date. Now, there's never enough data, which is why a few years ago we decided to implement this bring your own data capability so that users could onboard their own files in it. And the obvious choice to start with was Cloud-Native and ZARR. And now the question appears of which of these two is better, right? What to use? And I'll actually not answer this question. I'll leave it to others to discuss it. Because probably it very much depends on how the data is to be used. What I want to talk about, though, is the decision that need to be made after you choose between these two, which will actually result in whether the data collection is useful or not. Starting with Cloud-Optimized Geotips, first one is what kind of internal tiling to use. We see a ton of Cloud-Optimized Geotips which have a very small internal tiling, which results in a large volume of requests that need to be done and therefore slower processing. Now, if you use large internal tiling, you might end up with a lot of unnecessary download, but we did some tests, and as long as you are within the cloud, we realized that this download part is irrelevant, so we recommend the internal tiling to be on the larger side, like 1000 by 1000 pixels. Second one is what compression to use. Again, standard doesn't define it, but because we want to make an optimized data format, we definitely recommend to use one. Deflate seems to be an obvious choice unless you have a very specific reason, because it's a lossless and works very well. Now then there is a bit more tricky one on what kind of rescaling method to use. Typically for building the overview layers, people would use, I don't know, average or bicubic or something like that. But if you have a discrete value data collection, such as land classification labels, you will actually end up with errors. As can be seen in this example, if you look at the middle of the image, you see a lot of green and yellow patches. But now if you zoom out, suddenly blue ones will appear. And that's because the average of the value for yellow and for the green will sometimes end up being the blue, which is actually completely wrong. This is why we recommend to always use mode for the code lists, and then for the value ranges, the average works just fine. Then, if you are using multiband geotips, the question is which chunking to use, either chunky or planar. And it's a bit of a similar discussion to the internal tiling in terms of like taking too much of the data versus fast response. We would recommend to use chunky format because it has better performance, again, within the cloud. And last but not least, which GDAL to use. We realized that the old versions of GDAL had an error, and which resulted in the wrong values on the overview levels. So make sure to use 3.1 or newer. Now with ZARR, it's actually even more complicated because it allows more options for the chunking, and the decision of what to use depends very much on how the data will be used. If you are preparing the data for visualization purposes of the large areas, then you would typically choose the large spatial chunking. Now, if you are for the time series of the small areas, then typically it would be large time chunking and small spatial chunking. If you are building a collection which will be regularly updated, you might want to have small time chunking because you don't want to reprocess the last chunk too often. If the ZARRs are used in a geospatial domain, the question is where the coordinate system is defined. That's not something that is clear. And if you're having multi-resolution data like Sentinel-2 bands, which are 10, 20, and 60 meters, that's again something that is not well specified within the ZARR format. So it needs to be defined additionally. So I'll stop here, and if you're interested in more information, some links, and looking forward for your questions. Thank you very much.